Mm,
What was that, a noise or what was that, Brandon?
Mir.
Okay, so what's 2 copies of 3? What is 3 squared or 2 copies of 3? That means 2 copies of 3 is what?
9,
Good. And what's 2 copies of 4?
16.
Good. So what we got here in the square root is a square root of 9 plus 16. And how much is that? What's 9 plus 16?
Oh, 25.
And the square root of 25, remember what the square root means. It means to the 1/2 power, right? So I know that I can 25 as 2 copies of 5, right? But I still have my square root over it. So I still have this 2 copies of 5, right? But I got the square root. But I know the square root is the same as writing to the 1/2 power. So I can write this 5/2, 5 to the 2, and then raise that further to the power of 1/2, which what it means to be a square root. So this is power to the power rule. Power to the power rule says when you have x raised to a power, and that's raised to another power, that you're going to multiply the 2 powers together up here, x to the a times b. Good. So now I'm going to multiply 1/2 times 2, which I've done several times. You put 2, I could call that the red 2, for example. I could call that, that's the 2, and now I'm going to multiply it times the 1/2. Okay, I'm going to multiply it together. Now nothing's preventing me to put this 2 over 1, because 2 divided by 1 is still 2. And I showed you that you multiply fractions by going skiing. So that's 2 over 2. And 2 over 2 is 1. So now I know that this is just 5 raised to the 1 power. But guess what 1 copy of 5 is? That's right, it's just 5. So that's the famous 3, 4, 5 triangle. Right? And they have, now if you think about this angle, let's call this angle X, for example. And we'll think that angle Y. Which angle do you think is the bigger angle? X or Y?
X.
X. And why do you say X?
Because it has a wider angle.
Well, here's X, right? Right?
Mm-hmm.
X is this angle between this. So they're talking about this distance right here. But I think this is a bigger angle because look at the distance you have to cover this way. You see, the distance between here, B, is a bigger distance than A. So the bigger angle, I would call it Y. I'm saying what's bigger, A or B? Which is longer, A or B?
A.
Look at the numbers. A is 3.
B.
B. So that means that this angle here has to be the bigger angle because B is bigger than A. So if I call this Y, I'm saying that Y is greater than X because look at the distance. It's between the 2 lines is 4 and the distance between the other 2 lines is 3. You understand what I'm saying?
Yeah.
You understand why Y is a bigger angle than X? So because the angle between here and here, the angle between here and here has to be bigger than the angle from here to here, right? Because this is spanning a distance of 3 and the other is spanning a distance of 4. So the angle of green angle would be a wider angle, a bigger angle than this. Okay, and this other one would be the red angle. Okay, and in this particular case on the 3, 4, 5 triangle, this guy right here, you'll learn this in trigonometry. This thing is 60 degrees, the bigger angle. And that would make this guy here 30 degrees. The reason it makes it 30 degrees is because this is the right angle, which is 90 degrees. So the interior of any triangle is 180 degrees. So if this is 90 and that's 60, that's 150. So subtract that from 80, that leaves me 30 degrees here and 60 degrees here. A very special triangle, the 3, 4, 5. The Egyptians used it. They had a knot like a rope. And the rope would be like this, and then they had a knot, all right? And then they would call that would be like a unit. So they would have a rope that had 3 knots in it. You know, that these knots are like equal distance. And then they had a knot like this. And then they had 5 more knots. So then they know that this is right here, right? 3. and then they'd have 5 more knots. You know, they're all equal distance in this rope, but you could do a really good surveying over a little plot, like if you want to do a pyramid. So I got 3 dots here, and then I have 4, and then let's say 5. So what they did is they would put a spike right here. Let me show you, right here, and then they would turn. And so then they 3, and then they would turn. So they go 3, and then they turn 4 dots this way. And then they turn the rope this way. Let's go here. And, right, and then they go like this. They bend the rope this way instead of going straight. They go here. That's 1. And then they go like this, 2. And then 3. And then 4. 4 knots this way. And then they pivot again. They turn again. And it turns out always that then they pivot. Now they take the rope and they turn it around again, except this rope now will travel when it goes through here to here. This rope will have 5 knots in it, like this. Right, so it'll have 1 and 2 and 3 and 4 and 5. So if you have a knot here and here and here and here and here, so you could have a rope that has 3 plus 4 plus 5 knots, and it'll always make this right triangle. And they'll know that that right triangle will have, this will always be 30-degree angle. And so now they have a way of measuring out 30 and 60-degree angles by taking a rope and just putting 3 knots in it, and then 4 knots, and then 5 knots. So you have 7 knots and 5, right? You have 12 knots. And that will always track out, okay, there you go. You see, you could have a rope with 3 equally spaced knots, then 4 equally spaced knots, then 5 equally spaced knots. And that will trace out a completely perfect triangle with 30 and 60 degree and 90 degrees.
Can I show you the homework?
Yeah. Let me see what you do. Try 1 and 1. Enter it for values. That's 11. Yeah. No, now you have to enter. I don't know what you did. Okay. Enter 1. Enter 1. Enter. Enter again. There you go. That's right. 1.41 is actually the square root of 2. Or close to it. That's very good. Wasn't hard, was it?
No.
Not when you know how. So let's see. Let's go back up here. Right. So
what do you want us to do for the assignment exactly?
What you just saw him do. I don't know. Just write that code out. That was Mason, right? And that was solve C. So I want you to do an A. I'll give you a value of A and B and solve for C. So really, the homework assignment should say solve for C given A and B. So let me put 1 and 0 in here.
Okay.
You want to see the code again, or you got it?
Oh, no, I'm good.